In this video we're going to look at the eye, different features of the eye, and how light can be focused onto the retina. So let's have a start by looking at the different structures in the eye. You'll be most familiar with what the front of the eye looks like. So structures like the pupil, which is the black hole, the cornea, which is the see-through curved bit at the front of your eye, the iris, which is the coloured part of your eye, and the white of your eye, which continues all the way around the back of the eye, helps to protect it. It's quite strong, and that's called the sclera. Keeping your eye focusing the light is your lens, and that's held in place by ligaments called suspensory ligaments, and those ligaments are attached to muscles that can contract and become a smaller circle when you want to focus on near things, and relax and pull the lens flat when you want to focus on distant objects. Keeping the shape of the front of the eye, there is a liquidy medium in between your cornea and your lens, and between your cornea and your iris, and that's called the aqueous humor because it's quite liquidy. And the equivalent in the main eyeball at the back is called the vitreous humor, and vitreous comes from the same derivation as in vitro for IVF. Vitreous means glass-like, so it's much more jelly-like substance holding the shape of your eyeball in place. Just underneath your sclera is a blood-rich layer called the choroid that is fed by a blood supply which travels up in the same area as the optic nerve. And the inside of your eyeball, there is the retina that has all the photoreceptors, the rods and the cones that detect light. At the fovea, those rods and cones are most concentrated, so you get your most detailed view when the image lands across the little area of your retina called the fovea. And there is an area at the back of your eyeball where you don't have any photoreceptors because that's the exit point for the optic nerve, and that's called your blind spot. So these are all the parts of the eyeball. Let's have a think now about the energy transformations that take place, and these are very simple. Incoming energy is in the form of light energy, and at the back of your eye, on the retina, you have transformation of that light energy into little electrical pulses. So that's happening at the retina with the rod and cone cells, those photoreceptors. And the rod and cone cells look like this. They are slightly different in shape. The rod cells have pigments that respond to light intensity, so they allow you to see black and white. And the cone cells, there are 3 different types of this. They respond to different wavelengths to allow you to see 3 types of colour, and then your brain can mix and match those colours and blend them together with the tones of how bright and dim the light is to allow us to perceive colours. Let's have a think about how we focus, and the correct term for that in the eye is called accommodation. And this all relies on us being able to bend or refract light. So when the light enters the eye, the 2 features which bend the light are the cornea, which is right at the front of the eye, and this is fixed. This can't change how much it bends the light. The thing that can do the fine tuning of bending the light is the lens inside the eyeball itself. And as I mentioned before, this is held in place by suspensory ligaments which attach that lens to ciliary muscles. So as the light comes into the eye, the first thing it does is strike the cornea, and the cornea will cause it to bend a little bit. See a little bit of bending there. And then the lens will bend the light again, sending it in a straight line onto the retina, where it will come to a perfect focus right at the back of the eyeball, and you get crystal clear focus. Sometimes that doesn't happen, so we'll have a look at what happens if that doesn't quite work. So here is one condition where that's not quite working. It's called hyperopia or far-sightedness, and this means that the image is going to form beyond the retina, behind the retina. So when we're looking at things, they'll appear fuzzy, and that could be for one of two reasons. It could be that your eyeball is too short, or it could be that the lens is not curved enough, so you're not getting enough bending. So what's happening here, I'll try and draw it with my pen, is that when the light enters the eyeball, it bends very slightly at the cornea, but if the lens itself isn't bending it enough, the light will travel and not come to a fine focus until a point beyond the retina. So the cornea is struck, slight bending, and then at the lens we get bending, but not enough for that light to focus at the retina. So what we have to do now is correct this with glasses or contact lenses that cause the light to converge in front of the cornea. So we're going to help the bending inwards. So if I change color pen, you might be able to see what I mean. So this time we have the light coming in the same as before, bending the same, sorry, we need to put a lens in first, sorry, a convex lens here. So a convex lens is going to bend the light in. So we have the light coming in, it does a little extra bend before it hits the cornea, and then it's bent into the lens, and then the lens bends it again and sends it towards the retina, and it's landing now on the retina, just perfect. So we get to the lens here, bend a little bit first, hit the lens, and it's coming to a point on the retina. So on the retina here. So we've managed at this point in front of the cornea to do a little bit of extra bending, converging the light to give it a help so that we don't have it focusing behind the retina. Okay, so this is a convex or converging correction. The other type of disorder that we can come across is myopia or short-sighted, and that is where the focus point ends up being in front of the retina, so maybe somewhere here, and this might be because your eyeball is too long or the lens is too curved. So if we have a look at what might happen here, we've got incoming light, the cornea is bending it, the lens is bending it, and it's actually coming to a focal point in front of the retina there. This time we can correct this using a concave or diverging correction. So we're going to take the light out a wee bit before it hits the cornea. So I'll change color pen and we'll have a look if we can get this right. Get the lens in place first. A concave correcting lens is usually slightly wider on the edges than it is in the middle. So there's a bend which is going to send the light out a little bit before it hits the cornea, and then it starts to come in, and then the lens gives it an extra bend in towards the back. So slight bend and slight bend again, and they should be, it should meet at the back. I didn't do a very good job of that one. So it should meet at the retina on the back there. So we need to correct it so that we give a little bit of outwards movement of the light before it then gets bent inwards. So now we're looking at sending the light out, diverge it away, and then bring it back in to land perfectly, hopefully, on the retina, correcting this focus from in front of the retina to perfectly on the retina. And those are our main disorders.